in the first question, you are given 2 by 2 matrix where a rule is given for the entries of matrix. The Aij is I plus j choose I. Okay, determine the numerical value for the entries of A. So so Aij equals I plus j is I. In the first case, when this is a 2 by 2 matrix, so A is equal to, the first is 1, 2, 1, 2. So that's I, j. I is 1, j is 1 as well. So the first one is 1 plus 1, which is 2, is 1. Row 1, column 2 is 1 plus 2, 3, choose 1. And row 2, column 2 is 2 plus 1, which is 3, choose 2. And the last entry, that is 2 by 2 entry element, would be 4, choose 2, which should give you, it's like 2 factorial divided by 2 minus 1 factorial, 1 factorial, 3 factorial divided by 3 minus 1 factorial, 1 factorial, and this is 3 factorial divided by 3 minus 2 factorial, and 3 factorial, this is 4 factorial, and 4 minus 2, and 3 factorial, which should give you 3, 2, 3, 6. So that's the first part. And second part, ask you find the determinant of A. This should be easy. You just apply the form, like this is A times B. It's CD. So A times B times B times C, which gives you 12 minus 9. This is 3. And the third part is, if it exists, determine A inverse, or otherwise indicate the inverse does not exist. A inverse is given by 1 by its determinant, A which is not 0, so exists. And then we would flip this diagonal, 6, 2, and take the negative. Gives you 1 by 3. I'll factorize this. Computer play. Six minus 3 minus 3, 3, which dividing each element by 3 gives you 2 minus 1 minus 1, 3 by 2. Consider the column vector 1, which has entries 1, 1. Denote U is A times 1. Determine the norm of U. That's what you need to do. So norm of U is first find what is U. U should be equal to your A times 1 which is a row vector, and a row matrix that is 5, 9. So norm of U should be equal to square root of 5 squared plus 9 squared, which gives you root 61. And part 5. Take now n by n matrix A with entries Aij, is Ni. Let Ei be the n row vector. Let me check. Maybe I made an error. It's the other way around. Yeah, 10.06. Thanks. And Eij is Ei be the nth unit vector. Find a simple expression for sum. Eit to Ei. I goes from 1 to n. Which we have, okay. What is this expression? Yeah, if you write the square root of 106, square root of 106 and like the value, approximate value, okay, you should be fine. Okay, that sum is a scalar, but you know that EIT, AEI, this is equal to AII. Okay? This is equal to, according to according to the definition of the matrix, that would be an I, the matrix elements. So this sum really is equal to sum of I plus 1 to n. Is everyone okay up like to this one, up to this step? I hope so. This is really an I. Which is a, what is this? Can you recognize that? It's the binomial coefficient, right? Remember binomial theorem? Sum of 0 n h is still r to the power 2. This is equal to 1 plus r to the power n. So in this case, r is 1 here. So it's 1 to the power I, which is 1. And this is equal to 1 plus r is 1 to the power n. Okay. Oh, I missed one term. This is I equals 1, and plus there will be another term. Oh. If I start the series, then I equals 0. Take away I equals 0 term, that's then 0. That should be now equal to, in this form, I equals 0 to them, 1 to the power I minus 0. This is equal to 1 plus 1 equal n minus. This is 1 here. Okay? That's equal to 2 to the power n plus 1. Any questions? Question 2. You are given matrix M, the 2 by 2 matrices with real elements in the range -1 to 1. Set of 2 by 2 matrices. And N is defined as set of 2 by 2 matrices again. With elements in the set. Can I be the 2 by 2 identity matrix? first part is the statement I is an element of M, and N is a subset of M. Is it true or false? What do you think? True is both are true. Yeah. I is 2 by 2 identity matrix. Okay. So this is in the form 1001, which is an element of M. So that's true. And N is a subset of M. Yeah, which is true because N contains elements -1 and 1. So this part is also true. So true and true gives you true. Okay. Second is the cardinality of N. What is this? N is, yeah, 4 buckets, 2 holes, yeah. Or some says 26, some says 16. So each matrix has 4 entries, and each entry has two options. So 2 options for each. So that would be 2 to the power 4, which is 16. Determine the number of the elements. That's cardinality of the power set of N. What do you think? Is it the same? Cardinality, remember in track 1, I think last week also we did come across. This is the power set of N. So it would be 2 to the power the number of elements at N, which would be 2 power 16, okay, which you can find out. Okay. Yeah, it's 65536. Find an element X in N such that determinant of X is equal to 2. So you just give an example here. Okay? One example is enough. Yeah, we can take maybe -1, 1, 1, -1. If X equals this, what is determinant of X? -1 times 1. Oh, that doesn't work. Determinant is 2. This doesn't work. Let me try the other one. How about 1 minus 1? -1. So that would be equal to 1. I need a minus one. I need a minus one here. So that would be yeah, that worked. So if you look at the solution, so maybe these are not the best. This doesn't go. So x should be equal to 1 minus 1 plus 1. Okay. Please be aware of the solution posted maybe yesterday. I'll ask you. I'll ask the course coordinator to change the example. Yes. Oh, the second one does. Okay. Oh, the second one is what I said. Okay. The next one is part 5. Consider the column vector 1, which is entries 1 meter. Now for any 2 by 2 matrix X, denote X bar is transpose. What is the maximal value of X bar that can be obtained if considering all X in M? What's the maximum value? If X bar is equal to 1, then we have, this is really sum. This is a double sum. AIG. Which is should be given by is the sum of the elements. A plus B plus C plus D. Right? Yeah. So the maximum element is, remember, if X is in N, X can take values of only 1 and minus 1. Okay? So the maximal element is when all of them are 1. Okay? So maximum value is okay. And, A equals C equals C equals C equals 1. 4. Next part. Does the same answer hold if considering all xn? Briefly explain. Is this the same for the matrices n as well in the set n? Yes. Why? Because when you x bar is still the same here, so the maximum occurs, the maximum in n is that is in the range -1 to 1. Okay? So the maximum occurs again when all the elements are 1. Okay? Let's see. and A plus B plus C plus D plus 1 again. The next part of the question is it true or false? The complement of n, the complement of n in n is empty, implies I is not an element of n. True or false? What do you think? True is that is not true. That is false. Why? This is false. Why? Yeah, n is a subset of m. Okay, and implies something else. So this you can say is I not an element? Is I not an element of n? Is it true or false? This is again false. So false implying false would be true. This equals true. But you can see this as a logical equivalence as well. So this is in the form P implies Q. Okay? Is logically equivalent. Is the P or not P? Okay? P or not P. So if this is your P, so in this case, we got P is false or not P is true. This is equal to which is false, so if this one should be true, that's true. Then the next one is determine the value of the number of elements in n times n. What is this? This is the set of ordered pairs, okay, from n to n. That would be number of elements n, which is equal to what? 16 times 16. That's all about question 3. Let's move on to question 3. Question 3, proved by induction. 4 other means. Q is equal to n squared, n plus 1 squared. I think induction is easy. So let's do the first step, which is the basis step. Okay? Check whether if it is true for n equals 1. For n equals 1, left hand side is 2 equals 1, n equals 1, 1, 2, which is 1, and right hand side is 1 squared, 1 plus 1 squared, divided by 4, which is 1 times 2 squared, 4, 4, this is 1. Okay? So that's true. And so this step 2 is assume it's true for n equals k. So that means 2 plus 1, 2. K squared, 2 plus 1 squared over 4. Then the step 3 is the induction step. Check for n equals k plus 1. K plus 1. Okay. This is left hand side. Should be equal to 2 plus 1, 2, 3. Plus the k plus 1, which is 2 plus 1, 2. This part is from the hypothesis. K squared, 2 plus 1 squared over 4 plus 2 plus 1. This is equal to factorizing k plus 1 squared. That should be over 2. Factorizing this part should give you k plus 1 squared over 4 times k plus yep, plus 1 So on the right hand side, we should get, if it is k plus 1, that should be k plus 1 squared. K plus 1 plus 1 squared. Which is equal to the right hand side. Then we can say, therefore, the principal this is n. Okay, that's about quiz. So let me check. It should be a 4. So that factorization gives you, yeah, 2 times 2. So yeah. And inside 1. That's really k plus 2 squared. Okay. Okay, any other question? All right, let's move on to, I think I more than a lot of time for this, but let's look into chapter 4.7. 4.7 is about real functions of several variables. So you may come across, you must have come across functions of several variables before. It was like, for example, volume, okay? Or vibrating string is a function of a time. So the volume is a function of three variables, width, height, and its depth. And yeah, height, like times height times its width, okay? And the string, vibrating string is a function of two variables, a sin x cos t. And if you look at the plots here, okay, you can use plot 3D in Mathematica to visualize these functions. Okay, I will give you the plots in a notebook later on, upload it in the GitHub, because in this tip today I didn't have time to show you that. But let's look at the arbitrary planes. Okay, and then I'll give you the first example on how to complete planes. So equation of a plane in 3D is given by the equation ax plus by plus cz equals d, where a, b, c, d are constants. So what does it mean by horizontal plane, and what does it mean by vertical plane? Let's do this. In general, we've got ax plus by plus cz equals d, where a, b, c, d are real numbers, and horizontal planes. Horizontal planes are when z equals somebody z. So this is called xy plane. So if you have z equals some z, some value z, then this equation can be, if z equals z0, then you can say ax plus by equals d minus cz. So this is just a number, okay? So maybe call it s. Here, A, B, C are assumed not equal to 0, okay, in this plane. And vertical planes are given by, so in this case, if this is your x, y, z, okay, if z is equal to 0, that's the plane parallel to xy axis, okay, that's z equals 0. But for the other numbers, that would be z equal to n z0. Okay? It would be parallel to z equals 0 of that plane. And the vertical planes are given by two planes. So YZ plane is when x equals some number x naught. This gives you py plus cz equals d minus kx naught. Okay, this is again a number. Okay, and the other plane is xz plane. This could be when y equals y naught. That is ax plus cz equals d minus dy naught. Okay, this is again a number. Okay. Then let's look at example. Suppose x plus 2y plus z equals 4 is the plane. Find the points which it intersects with each axis. Okay? How would we do this one? Intersection point is axis intersection is when each axis point is 0. Okay? So at x-axis, this is how you would draw the plan by hand. Okay? This is called triangle method. Okay? It would uniquely define the plane, equation of a plane. That would be at x-axis, we have y equals z equals 0. So that gives us so the point that intersects with x-axis is 4, 0, 0. Okay? At y-axis, we have x equals z equals 0. So that's the point 2y equals 4. This gives us y equals 2. So that point is 0, 2, 0. And at z-axis, we will have z equals x and y 0. So z equals 4. That point would be 0, 0, 4. Okay. Now, to sketch the plane, you could join these lines and points and then draw the plane along the lines. So 400 is maybe somewhere here, and 020 is maybe somewhere here, and maybe 4 here. And then you can use in Mathematica, you can use the contour plots to contour plot function to plot these plans. Okay, so I will give you the codes later on the top. Please check for it. Okay. The other question is example 2 is find through the points 0, 0, 5, 1, 3, 2, and 0, 1, 1. So all what you need to do is you sub these points to the plane ax plus by plus cz equals b, okay, and find the values. Okay, but it would be easy if you could rearrange this equation to make z the subject. So that would give us c equals b over c minus a over cx minus b over c y. You could say this is these are p, q, r, y. Okay? P, q, r are real numbers again. And then at 0, 0, 5, we get z is 5. So 5 equals your p minus 0 minus 0. Okay? So that gives p equals 5. And then at the other point, 1, 3, 2, we have c is 2 equals p, x is 1, so minus 2, y is 3, so minus 3r. Or you could also say this is, sorry, you could also say this is plus, so you got plus, plus, plus. Substituting this to p5, we get plus q plus 3r. Let's say this is equation 1. And then we got at 0, 1, 1. Sub the other point, and then solve. You should get another equation. Okay? You should get r is equal to minus 4 from this, and then sub r equals minus 4 into equation 1 and get the values. Okay? So your equation of the plane should be 5 plus qx minus 4, 1. Q is 9. So okay. That's where we will stop today. And I'll give you the contour plots and the 3D plots codes later on GitHub. Okay. Thanks for attending.